Section 1.9 Probability by Kieran Beckham. Our objective after studying this section is to be able to solve probability problems. A knowledge of probability is obviously important to an insurance company, to a card player or a backgammon expert, and to the operator of a gambling casino. Moreover, setting up and solving probability problems requires the precision and the organized, ordered thinking needed by secretaries, accountants, doctors, filing clerks, computer programmers, and geometry students. Although probability is not one of the major topics in this book, you will occasionally encounter probability problems in this problem sets. You can analyze such problems by following a simple two-step procedure, as shown below. Here's the procedure. Step 1 is you want to determine all possibilities in a logical manner and count them. And then step 2 is determine the number of these possibilities that are favorable. We should call these the winners. The equation for calculating probability is that probability equals the number of winners over the number of possibilities. Here's our problem. If 2 of the 4 points are selected at random, what is the probability that both lie on line CA? So here's line CA. And when we follow the 2 basic steps by listing out all the probabilities and circling the winners, we can get our answer. So remember, probability is equal to winners over possibilities. So we have all of our probabilities listed out here. We have 1, 2, 3, 4, 5, 6. So it's the number of probabilities, therefore it will go on the bottom. The number of winners, we have 3 winners. AB, point A and point B. BC, point B and point C. And AC, point A and point point C, because they all lie on line CA. Ray CA. So because we have 3 winners and 6 possibilities, 3 over 6 is equal to 1 over 2. Therefore, the probability is 1 over 2 that 2 of 4 points will both lie on Ray CA. So as you can tell, probability is pretty simple. You just have to know how to count all of the possibilities and define the winners of each problem, and then make a fraction out of them, and you'll get your answer.
Section 2.1. The objectives of this section is recognizing the need for clarity and conclusion and concision in proofs, and understand the concept of perpendicularity. In Chapter 1, we concentrated on 2-column proofs, but we were also exposed to paragraph proofs. From now on, we will only use 2-column proofs and try to state each reason in a single sentence or less. The point of this section is to help you do that with many problems and hints. Perpendicular lines, rays, and segments. Perpendicularity, right angles, and 90-degree measurements all go together. The definition of this is lines, rays, or segments that intersect at right angles are perpendicular. These are some examples of perpendicularity. These intersect at a right angle, these intersect at the right angle, and these intersect at a right angle. In the figure to the right, the mark inside the angle indicates that angle B is a right angle. It is also true that segment AB is perpendicular to segment BC, and angle B is 90. This tells you that it's equal to 90. We cannot assume that perpendicularity from a diagram. In triangle DEF, it appears that segment DE and segment EF are perpendicular, but we cannot assume so unless we know angle E is 90 degrees. In algebra, we learned that 2 perpendicular number lines form a 2-dimensional coordinate system, or coordinate plane. The horizontal line is called the x-axis, and the vertical line is the y-axis. Each point on the plane can be represented by an ordered pair in the form x, y. The values of x and y in the pair are called the coordinates, and they represent the points distances from the y-axis and the x-axis respectively. In the diagram, point A is represented by -1, 3. The intersection of the axes is called the origin. Its coordinates are 0, 0. Problem 1. We're given that segment AB is perpendicular to BC and segment DC is perpendicular to BC. Our conclusion is angle B is congruent to angle C. So if AB is perpendicular to BC, that must mean angle B is a right angle. And if DC is perpendicular to BC, then it has to be a right angle. So it says here that means angle B is a right angle. If two segments are perpendicular, they form a right angle. And angle C is a right angle, which is the same reason as 2, which is if two segments are perpendicular, they form a right angle, which means in conclusion, angle B is congruent to angle C. We're given line EH is perpendicular to line HG. We need to name all the angles you can prove to be right angles. The answer is only EHG. So we're given that HE is congruent or is perpendicular with EH. So that means this angle right here, HEG, is a right angle since it's equal to 90 degrees.